collection of assignments that will a piece of Python software, but also the supporting documentation and things like flowcharts and IPO charts that you'll be incorporating into a nice chunk of software. That's our plan, and we obviously don't have it quite ready yet. So I guess that's just a reflection of, I guess, going online suddenly this fall and switching to Canvas all at the same time. So we're not as organized as we'd like to be. So I apologize for that. But when we get the assignments up, we'll obviously give you enough time to do them, and you'll have opportunity to work on them. Any major questions or issues? Anything anyone wants to ask me about right now before I get started? Things are going okay? So if you're not...
Sorry. So I got kind of lost, but did you end up talking about like putting up the next modules?
That's an issue as well. Where would I see that? I would see that under maybe...
Because we still just have the modular programming.
Yeah, we should have the Boolean and conditional logic quiz. When you say module, that's what you're referring to, the activation of the quizzes?
Yes.
Yeah, it's supposed to be live and it's not. And I guess logic with repetition is coming up very quickly as well. I don't think he's going to do that one, the testing and software quality. It was somewhat of a disconnected topic anyway, so I don't think he's going to get it.
Okay.
I don't have firm answers for you, but they're
Just hold on tight.
cool.
All right. Do you know if they'll
Yes,
like be on like during the weekend then, if it's the 25th, if it's due the 25th, or would it be like pushed? I'm assuming.
well, we would never launch anything at you on Saturday and say it's due Sunday. Like, we would never be that restrictive. Like, there will always be time to work on things.
Okay.
So all of the dates that you see on Canvas are pretty much tentative dates, with the exception of there's one date that's firm, and that's our final exams. We have to be done by that week.
So is it going to be on Saturday, December 19th?
No, that's when it has to be done. It'll be scheduled by the college, and you'll be given a date. So whatever that week is, 16, 17, 18, 19.
Okay.
This exam will be one day, but I don't know which day yet. They haven't told me either, but they usually give us a month notice. It's like I expect it in November sometime to get the schedule. So if you're planning to go home or trips or anything like that, we usually have the dates all figured out, but don't buy a plane ticket anywhere unless it's outside the exam window. You can be writing right up to the Saturday, though our department is almost never on the Saturday. Our department's almost always done by Friday. I don't know why they say Saturday. I think business goes Saturday and we don't, or something like that. I don't know.
But the last date is December 18th.
No, the last date is technically December the 19th. But I rarely see an exam on a Saturday. Like, I mean, I don't remember one. They always get us done by the Friday. But officially, the exam week goes to Saturday. So that's the official college warning. If you're booking a flight, book it for the Sunday or something if you're planning to go somewhere.
Sorry, I just joined and I have to ask, like, do we have an assignment due Saturday or what? Because like the date shown on the screen here.
Yes, you just joined because I just finished talking about that. Yeah.
Yeah, sorry.
It's okay. It's not ready. We are trying to get them ready. You have nothing due this Saturday.
Okay, thank you.
There's no way we can give you short periods of time. You always have to have time to work on stuff. So all of these dates are going to be moving,
Yeah,
or maybe it'll become 3 assignments instead of 4, because the next 6 weeks are really busy. Between tests and assignments, things are getting squishy now. So we will figure out a way to get her done. Unfortunately, I'm at the mercy of working with my coworkers, which is okay.
thank you.
Which is okay. What happened to my computer? There we go. I'm back. All right. Last class, somebody asked a question, I can't remember who it was, about truncating a floating point number. I was working in, where was I working? I think I was doing this example with the bug 2, and we had this expression in the print where we format numbers with 0.3, and this will round off. Like this will go to the 4th decimal place and round off going backwards, which is good. I mean, that's a feature. So somebody had asked about how do we if you have a great big long floating point number, how do we display that with without rounding if we want to chop it off at a particular spot? So the first thing that came to my mind when that question was asked was converting it to a string and substringing, because substringing is actually pretty easy to do in Python. So that was the first thing that came to my head. We haven't done those string operations yet. So I wasn't really sure of a math way, but there's, of course, lots of options here. There's probably 10 different ways to do this. One approach, if we pull in the math library, so notice I did an import. So math is not part of the Python standard library. So we use import statements to bring in libraries which are already installed on my computer, but they're not directly available in Python. I have to tell Python I want to use it. So if I have a if I want to invoke a function, so this is a object.method, so it's math.trunc. Trunc stands for truncate. And I feed it my variable data, it chops it off at 12. And there's no rounding there. So that's just truncating. So that's kind of close to what we wanted to do, but it's not at 3 decimal places or 2 or 3 or 4 decimal places. It's just chopping it off at an integer, which has its uses, by the way. That's a handy function to have, but sometimes we want to maintain some of the decimal points. So if you take your data and you were to multiply it by 100 and then divide, you get the answer you want. You get back to where you wanted to be with however many decimal places you want to preserve, and there's no rounding. So that's one neat little tricky way of doing it. The other approach, the first option that came to my head was to convert the thing to a string. Because when we take a floating point number and convert it to a string, strings come with a very rich feature set of how to manipulate them. String-like data is very common and very friendly to working with strings. So this is a perfectly valid approach as well, is to substring the thing and extract out the part that I want to extract. So now the variable small at this point is a string, and that's okay. I can always convert it back. So this thing that I just slapped in there, it's called a slice, and we're going to do this next week. So I'm not going to explain this in any detail right now. Basically, I'm just going 0 to 5 and grabbing those positions or indices. Once I convert it to a string, it acts like an array, and we can have a lot of fun with it as an array. So if I really wanted this to be a floating point number, I could convert it back to a floating point number using the float command, and it looks the same when I print it, but it's a number now. So I can start doing math on it, like I can multiply it by 3 or something like that, and it's back to being a number. So those are the two solutions I found fairly quickly of how to truncate a float. And there's probably a bunch of other ways you could do it as well. Any questions about that? We're going to do, if you want to read a bit this weekend and do some new things, we're going to get into string operations on Monday, which is really introducing arrays. So there's no other way to say it. We're starting into working with arrays when we want to work with strings, because they are naturally in Python. Same thing. All right, back to my canvas. If you go to modules and scroll way down at the bottom here to my area, you'll notice a couple of PNG files. These are image files. If you want to grab these and look at them in your own on your own local machine, it'll probably look better than looking at it across Zoom. So there's unnamed.png and one called trace table. If you want to grab those, we're going to do some little exercise with those guys. Excuse me. On a test, we can't really make you draw flowcharts because there's just no way to make all these goofy symbols and arrow lines and stuff like that. So it doesn't really work on a test, but we can give you a flowchart and ask you questions about it. So one style of question is trace the variables. So do not take this and start writing pseudocode. Don't tell me in words everything that's going on in the flowchart. That's not what the question's asking. Read your exam paper carefully and just read what the question is asking for. If it's asking for you to trace the variables, then just make a little chart and write down every value, every bit of data that goes into each variable. It's not complicated. You just have to be neat, and you have to be thorough, and you have to keep track of everything that's happening. So when you read it, we see right away we have a number that is input, and then we have an X and a T variable. I have no idea why the T is there because it doesn't get used again. So it's kind of a strange one, but
Yeah, I was gonna ask, what would
Go
they
ahead.
put? Like they put the variable t, but then in the next step they put number equals number minus 10. It would have made more sense if it was like t minus 10 or something like that. At least you use a variable, right?
right. So this is a completely useless program. It doesn't actually do anything. It is just a made up flow chart. So don't try and make sense of it. Don't try and figure out what the program's doing.
So in the replace of t, it's supposed to be x, right?
No, T equals number. X is a separate variable. We start off with X equals 0, and then we add 1 to it. We'll walk through this one slowly, and I'll explain what I mean. So I'm doing this in Word, but you can just type out the variable names on a test and just write them. You're not going to necessarily make a table, but you should label what you're working with and just keep track of everything. So I'm telling you what to use for input. If you're not told what to use, then then you'll have to make something up. But if you're told, use this as your input, then go ahead and use that. So this is your number that you're inputting, and just follow through the steps. So what happens to X and what happens to T? Which one was which again? T, I forgot already as soon as I looked at it. X equals 0 is what I'm trying to say. So X equals 0 and T was equal to number, correct? So we put in T is also 45. Just keep going. Follow the arrows. Go ahead.
Did you give out any number?
In this particular example, I'm giving you data. I told you to use 45. So put it, yeah. If you're not told values, then you'll just have to make up some. Use 100, use 5, use whatever you like. So right now there's no output, so we can just continue on with the flow chart and see what happens to it. So number goes down by 10 and X goes up by 1. Number goes down by 10 and X goes up by 1. Now you can leave this one blank if you want, or you can fill it in. If you have a value of 45 in T, and the next row down is an empty cell, it's understood that an empty cell means no change. So if you want to type it in, go ahead. If you'd rather just leave a blank, it's fine. I'm going to mark it correct either way. We still don't have any output. We're still just in this loop thing running around. So it continues the same pattern. And we get down to 15, 3, 5, 4. So the critical point in this flow chart is this question here, is number less than 10? So right down to 15, the answer is no. So we just keep going around in circles. When the answer is yes, there's only one thing to do. We output X and number. You put that on another line if you want, put it on the same line, doesn't really matter. It's pretty clear what is happening. Have you traced the values of all these variables moving through this program? The answer is yes, of course, you have. So you can just keep going with that concept and do -2 or 20.5 or whatever. So why don't I give you 5 minutes and you guys do that? So grab whatever. You can use Word if you want, or any other, just use pen and paper if you like. You're not handing it in or anything. 10, 20, 5 minutes. Go ahead.
You want us to
I want you to
use
do
like
this. I want
different
you to
numbers?
Yeah, I want you to take -2 and fill in the chart. Just add another row. Just keep going, and then do it again. Do it again with 20.5. Okay?
Yeah.
This. When I'm in Word, if I want to add a row, when I'm in this last cell, I can just press the Tab key, and Microsoft Word will conveniently add rows for me. Yep.
So, sir, like as you, wherever like you added 45. So now you want us to use the other numbers you asked us, right? Like -2.
You are running this program again, and when you input a number, you're going to input a -2.
Oh, okay.
So think of it as a brand new start.
Oh, okay. I was confused. I said, do I have to use even 45? That's why. Can you please go back to the chart? I just wanted to see like what two numbers you gave us, like -2 and 20.5. Okay, thank you, sir.
Okay. I'm lazy, so I'm not going to type the whole thing in. I've already typed it in, but the pattern's the same. You need to keep track of where you are and what you're doing, and just fill in the chart. And just when you're done, you're done. I think when you see how they work, they're fairly straightforward. If you misunderstand the flow chart, I guess you can get going off in the weeds sometimes. So notice what I did here. This is my, I'll put this up on Canvas later. Notice what I did here. I have from, where did I get it from? Did I create this flow chart? No. I found it, there's a whole website devoted to these problems. It was quite funny. Anyway, I just grabbed a couple and said, we'll use those as class examples. Is that legal? Yes, it is.
Sir, if you don't mind, can you please like go like use the negative to and can we like solve it?
-2, subtract 10, x is 0, add 1. This number is less than 5, you're done. That's it. Like that's all that's happening in that program. Because we start at -2, it goes to -12 right away. Does that make sense? When we go to -12, we're immediately less than 10, so we're done.
Okay.
X starts at 0, X goes to 1, print, output. Just follow the arrows, do the math. Not too bad, right? Not too bad. What I was referring to was, where did I get this from? And it's important that you say where you got something from if you didn't write it. So I didn't create this flow chart. I got it from somewhere. And in the academic world, we're given a lot of legal permission to use things for academic purposes. And there's absolutely nothing wrong with this as long as you say where you got it from. If you use something that you found on the web and you don't say where you got it from, then you're implying that you created it. You're implying that you're the author, and you're not. So that's wrong. So that's unethical. That's bad behavior. Just because you found something on the web doesn't mean it's yours to use. That's not true. It's a little bit more complicated than that. But we do have a lot of leeway in what we're allowed to use for academic purposes. So these people make these things publicly available and absolutely encourage us to take them. So I can put that in my class, and it's okay. There's nothing wrong with that. Back in Canvas, the other image, trace table example, ORIG. Where's my arrow? Here it is. Grab this one and take a quick peek at this. This flow chart has a little bit more going on in it, but not that much. So it's got 4 variables. Engine count, number, and size is input. So 3 of the variables are initialized to 0 at the start of the program. Size is input. Follow through everything that happens going around in circles and keep coming back to here to input size again. So I'm going to give you a bunch of numbers for size that you can input. The other 3, engine count and number, are going to be manipulated by the running of the code. So I'll put the numbers up. If you can get this PNG file off of Canvas, then you'll be able to see both. There we are. This will be your input. All of those numbers, as you loop around, keep inputting these values and fill in the chart. Fill in everything that's going to go in here. So the very first row is going to look like 0, tab 0, tab 0, 1.8, because the very first thing I input is the 1.8, which goes into size. follow through everything that happens and come back, and eventually, if everything goes correctly, you should eventually hit stop and with some kind of output. So I'll leave those numbers up. I've got 1031. Let's go 10. Let's do 10 minutes. Fill this thing in. Questions?
Sir, what does the small arrows inside of the small boxes mean? Like average, or well, it's pointing the other way, but you know, in between average and engine number.
You can think of those as an equal sign. So engine equals 0, count equals 0. You're initializing the variables to 0.
Okay, thank you.
Good. All right, what do you think? Super easy? Kind of easy? Anybody lost? Hopefully that's not crushing anyone. You may have missed a line somewhere or something like that, but the basic flow of it is okay. Any major problems? This document will go up on Canvas later, so you don't have to try and write it all down.
Sir,
Yes?
can you please try to work with 2.0, like the number you gave, the inputs?
Two,
Just wanted to see if I was.
this one.
Yeah.
So we've already gone around once with when you put in input size of 1.8. This is a no. It's a yes. So your count should have changed, right? When you have a 1.8,
Yeah.
your count goes up. And then the number goes up, and then the engine goes up by engine plus size. So that should all be reflected in your chart here. As you go from 1.8, all of these values should be reflected in what just happened with 1.8. So when you hit 2.0, you're starting another loop, and you enter the 2.0 here, but then you've got to keep track of what the variable was as we manipulate it as we go forward. So size is a no because we're not -1. And then you just follow through these same loops. Count goes up by 1, number goes up by 1, and engine changes by engine plus size. So they keep.
No, like I just understand how did it become like 1.8 then, the engine, like in 2.0 size?
In our flow chart down here, we have engine is equal to engine plus size. So the very first time through, our engine is 0. And when we get down here, we're going to add 0 plus 1.8. Which gives us an answer of 1.8. You okay with that?
Okay.
There's a lot going on in this one. I mean, this one is a little bit busy, but I think it's doable. I think it's manageable. So I'll put these documents up on Canvas, and you can always try them again later and test yourself and see if you can follow them through. So if you get stuck, just let me know. But this is kind of the level where we want to be. We want to be able to do these kinds of problems. And they're easy to mark. It shows me you can read a flow chart. It shows me you can keep track of 4 things changing at once. Good test questions. And they're really easy to mark because I just read down a bunch of numbers and go, yep, you got it. And I just see where you went wrong really quickly. Okay, let's do something similar but different. This is not up on Canvas yet, so don't write it down or go looking for it. I want you to read this. I don't want you to run it yet. You can run it later if you want to. So the last question, we were working with a flow chart and trying to trace variables. We can do it the other way on a test as well. We can also say, here's a program, trace the variables. Now, the way that I've worded this, I said, what will it print? Well, if you're giving code that doesn't have a print statement, then that's not going to work. So the question, when you see it on a test, it may just say trace the variables. They're the same thing. You just have to record all the changes, and much like we did with the flowchart example we just finished. Just keep track where everything is. So what's going on here? Got a bunch of variables, terribly named. Part of what I'm trying to illustrate here is variable names that look the same are very unpleasant. They're very difficult for people to read. So that's part of what's happening here. Anyway, I initialize them. There's no inputs here. You're not inputting anything. Just grind out the while loop. Notice the while structure is horizontally tabbed once. That's what defines the lines of code that belong to the while loop. It's the horizontal tabbing once.
Sir,
Yes.
does the minus sign, like minus and assignment operator, does it?
You're referring to this line?
Yes.
Yeah. So this is the same thing as, it's the same thing. It means take the variable, subtract 1, and store the result back in the variable. Okay? Same thing.
Yeah. Thank you.
Yeah, that's okay. We've seen that one before. When you have nested structure, we have an if statement inside our while. Notice that there are 2 tabs because the block of code that belongs to the if has to be physically offset. If you put this line 15 over here, it looks like it belongs to the while loop, not the if block. So in a small program, this isn't that hard to do, but as you get into bigger programs, you have nested structure. You have while loops inside if loops with more if, and it's all inside a function, and functions are tabbed over already. So you could end up with four or 5 tabs, and it's easy to make a mistake. It's really easy. So there's no other punctuation in Python that tells you what does a line of code belong to, what block, other than this horizontal tabbing, at least the way that we're writing it right now. So pay very careful attention to that. So we've got another operator here. There's plus, there's a minus. Don't forget what modulus does. This is a operator which returns a remainder. So we are going to perform the division, but we are not returning the result of the division. We are returning the remainder. So mod 2 is a test for even odd. Regardless of what bundle is, the result of this expression will always be either a 0 or a 1. 0 if they're even, 1 if they're odd. And then we have a print. So read carefully and write down everything that happens to each of these variables, batch, bundle, bunch. Write down all the values. I've got 1049, so at 11 o'clock, I'm done. I'll shut up, go ahead and work on it, and write down everything that happens to these 3 variables. All right, how did this go? Managing? Easy? No? So the first thing to point out, I didn't mention this before, so I was trying to see if you would catch it. What does this 0 mean? This 0 refers to the position within the format argument list. So we have bundle is going into this curly bracketed expression. But the 2 is out of order. It comes from batch. So if you got the right values, you may have had the columns switched. The way it's written here, bundle, bunch, batch, is not the way it's printed, because 2 I put in the middle, and the 1 comes from here. It comes from bunch. So that's just a little trick, I guess you could call it, if you saw it or not. I was just trying to see if you were paying attention. The other thing in this program that's a little bit challenging is this int, because it's not really obvious exactly what's that going to do. So if we have the Python interpreter here, we can do stuff like this, and we can get some experimentation in it and look at what it does. 19 divided by 20 is obviously less than 1. But when you force it to be an integer, it does not round up. It does not look at the 9 and convert it to a 1. So forcing floating point values to integers is a truncate. So if you didn't know that, that makes this line of code a little bit harder. But nobody asks either. So anyway, you do have to know some Python to answer these kinds of questions. So those are the 2 things in it that were kind of, I don't know, harder or trickier. 2 ways to get out of this while loop. If bundle were to be equal to 0, get out that way, or we could get out on the exit, depending on when bundle is changing or how it changes, exactly how we hit that. Anyway.
So, sir,
Yes.
so we already like go out in line 13, right? Since like it's true.
If that's where you hit, if bundle hits a 0, then you would exit. Yes, you would exit the program.
Yeah, because in line 13, if like since I got like 20 and then I do 20 minus 1, I get 19. So you know, I can't go to line 14, like it'll make it false then.
Okay. Okay, I'm gonna run the program and show you the correct answer. So that'll, I hope, help. What do I call this? So that's my answer, and without going through every line of it, hopefully we're getting close. Are people way off, or people happy? Kind of close. I didn't put headings on it because I didn't want you to see the order of how I'm printing it. I wanted you to see that. You didn't reach any print. Is that what you said? Okay, let's go through. Let's go through this a little more slowly. That's okay. While bundle greater than 0, we're at a 20, so we're okay. So we go down to 19, so that's all right. So we skip over line 15 because our bundle is at 19. We're going to modify bunch, and we're going to modify batch. Now, right away, bundle was 19. That's okay. That's okay. That's why we're here, is to step through these and make sure that we understand what we're hitting. So the very first time I hit line sorry, line 18, bundle is a 19, and we should immediately print. So our very first print statement should have 19, and then the changes that we had to the other two variables, which are reflected by these two lines here. Oh, this part. Yes, so the 3 here is referring to the 3 here is referring to is the field width. It's how much space am I reserving? So when I did the floating point values, this is the previous example, and I wanted to do a floating point number, I used decimal 3F to indicate three digits after the decimal point. When I did this example, that 0 is the field width. So if I made that a 9.3, then the field would be 9 wide. And the 0.3 is 3 digits after the decimal point. But in this example, I'm not dealing with floats, I'm dealing with integers. So the 3 here is by itself just field width. How much space do you want to reserve? And that space is a real space. The space that is typed in between the curly brackets, that still occurs. So if I were to put a bunch of junk in here, this junk would come out. Like it's just part of the print. The formatting is looking for the curly brackets to say where to put bundle goes into the curly bracketed field here. Is that okay? Making sense?
Sir?
Yes.
So as you said, like we got 19, like till line 13, and then we skipped till like line 16. Now the line 16 and 17 is a bit different. Like I was getting confused over here. Like,
Right.
can
So
we please work?
the very first thing I did was batch divided by bundle. So bundle here is a 19 and batch is 10. So I demonstrated the action of the int. So that's 10 divided by 19, which is less than 1. So that will make bunch a 0. First time through, which we see here. And then what happens to batch? Batch goes 10 plus 2 is 12. So that's our first pass through the program. That's our first pass through the while loop. You sort of have to get off to a good start, because if you get started bad, then these programs can really go ugly quickly. But if you get off to a good start, they usually go all right. You just take those values and you loop back up, and you do have to ask the question, is bundle greater than 0? And I think it's a 19 now. If I'm doing this off the top of my head, we have a 19 there. So we subtract 1 and we continue.
So when we come to like line 18, like they say if bundle is equal, so for bundle we found 19, so it's like 19 module 2, but I don't think it's gonna give the same like result.
The first time we go through, the very first pass through the while loop, bundle is a 19, and that is true. The mod 2 is equal to 1. So we will hit a print when bundle is 19. But the second time through, bundle is an 18, and this is false, so there's no print. So if you look at this thing, it seems to jump every other one. So this is our batch, and it's not going up by 2s, it's going up by 4s. Because this is 12, 16, 20, 24. We're going up by 4 because we're doing this plus 2 every time, but we're only printing the values where bundle is odd. So if you look at all the bundle values, they're all odd. There's no evens, because when bundle is even, we don't print. So you would write down something different if the program just said trace the variable. So I said, what will it print? So you have to key in on line 19. But if there was no line 19, if we just took that out of the program and it said trace the variables, then you'd write down everything. You'd write down batch goes 10, 12, 14, 16, 18. You'd write down everything.
So when you print it out for like, did you get something?
Say that again?
Well, like I don't understand. Like what does it print like in line 19?
I'm printing my 3 variables, which I pass into the formatting. And I just made nice space for them. If it makes you, when you get a hold of this program, you can of course manipulate it and rewrite it. But what I have done is this. It's all going to be squished together. So if you ran that, it's going to look like hell. I mean, even if you comment out that line, it's still going to look like hell, because these 3 variables, because they're a comma separated list, they're all going to be squished together. So by using the format function on a string, I can control the width of a column. I can give myself nice, neat columns, and the output is very readable. So my eyeball can go down the page and everything lines up nicely. But if you try and run the program, let me see if I can run it here. Did I save my file? So if I save the file and run it now, I don't think you're going to like the output that comes out of it. I mean, it's there. It's all squished, So this is a terrible thing to have to read. You want the columns to all be lined up nicely. So format is the easiest way to do that. If it helps you understand Python, if it helps you understand the exercise better, you are more than welcome to rewrite this. Like, just take my exercises and play with them, by all means. But line 20 is all I'm doing. I just want it to look neater. So I use this version because this version is going to look a lot neater. But this is how you're going. Sorry, go ahead.
Yeah, regarding like line 19, I just want, like, I understand what the curly brackets are for, so 0 column 3D, but I just don't understand what's the D for. So in the previous example, you used the F to address the floating point or something like this.
Good question. Good question.
Yeah, but the D here, like, I don't know what is it for.
It is referring to the data type. So D is for decimal, and we used F for float, and we've also used S is for string data type. Those are the 3 that I've used. I haven't shown you any examples. So
yeah,
D,
so we use these curly brackets, and then we use like dot format so that every variable takes its like position in in what you mentioned before.
yeah. So this 0 is very
Okay.
important. That's the position of bundle, and bundle goes into this curly bracketed mask or placeholder.
Okay, thank you, sir.
Good.
Sir, isn't like this like floats and like decimals same? Like you said,
No.
like D is decimal or integers, and like F for floats.
Yes. So float is a real number, with fractional component. So when I have a 0.95, that's a float because we have the decimal 95. It makes it a fractional component and it's a real number. So D is for decimal or integer, meaning there's no fractional component.
Oh, okay. Now I get it.
Sorry. What if bundle equals 0 and then why is it exit 1?
Exit will get us out of the program. It does not jump us out of the loop or anything fancy like that. Exit is kill, like you're done. So you are gonzo.
Okay, but can't we do the exit without the 1 in the bracket?
Normally when we leave, we provide a return value. So let me see if I can remember what it is in DOS because I can't remember what it's called. Let me see if I can take a quick guess at it here. There it goes. I can't believe I actually remembered that. So there's the 1. So we are returning a value to our calling environment. So as a programmer, you can make stuff up. Like you can make up exit codes. What does 99 mean? I don't know. But if I was a programmer, I could choose to make 99 mean something if it was a particular status that my program was ending with. So if I run my program now, program runs, and we look at the error level, and so you're going back to the calling environment. You always have the opportunity when a program ends to feed it a code.
Okay.
Do I have to put a 1 in there? No. I mean, I could put a 0, I could put a 27 if I want to. It doesn't really matter. But exit usually has an argument. That's kind of beyond the scope of first semester.
Okay.
Good questions, though.
What needs to be satisfied in order to exit 1? Like what number or in the entire program makes that 1 exit, I guess is what I'm trying to say.
There's an if statement there with a condition that has to be true. So when the bundle equals 0 is true, we will hit line 15.
Thank you.
The only place that bundle changes, if I remember my program correctly, the only place it changes is line 13. So this is kind of, it's not useless, but I just put it in kind of for fun. It doesn't really hit it because when bundle is a 1, we stay in the while loop. We drop down to 0 and exit. So we never actually come back here to test that because we hit line 15. But that's just me being silly. Is that okay?
Yeah, thank you. I appreciate that.
Good, good. These are good questions.
Sir,
Yes.
weren't we supposed to run it only once? Like when you try to run it, like I've seen like many, like, you know, I don't understand.
So bundle begins at 20. The very first time we go through the program, it hits 19. But there's no way out of this loop. Like we're staying, this is iteration. So everything that's in the while block is going to repeat, repeat, repeat. So we go down to 19 the first time through, and then bundle does not change. So we go back up here and we go to 18, and bundle doesn't change. So we're looping again, again, again. So we are going 19, 18, 17, 16, 15, 14, 13, all the way down to 1, 0 is true, exit. And because I only print the odd numbers, we do not get 20 lines of output. We get the odd numbers for bundles. We get half the output you were expecting.
So why didn't you use like the even numbers, like 18, 16?
Because I tested for oddness at line 18. When I said, give me the modulus 2 equals to 1, this is only going to be true when bundle is odd. So if I were to change if I change the program to be a 0 there, then that would completely change the output, because now we would be hitting all of the even numbers, 18, 16 going down. So that would be a completely different output. I said 1, so they're odd.
Sir,
Yes.
this might not be like what I know. This isn't right now what you're talking about, but is the updating of how it's after it ends the loop and it updates, the variable, is that recursion or no?
This is not a recursive algorithm. So we call this iteration. That's the fancy word we use for it. Means going around in a loop. So the word recursion is a function that calls itself. And we are not doing that in first semester. You'll do that probably in second semester if you go software anyway. So we use the word iteration to mean looping.
Okay, thank you, sir.
Beauty?
Sure, I have a little off-topic
Go ahead.
question here, but it's
Go
sort of
ahead.
related to. Say if I just wanted to get like all odd numbers, so from like 0 to 20, is there some kind of function that would allow me just to say, oh, can I get all numbers that are like odd between 0 and 20?
So there's probably, I don't know, 5 different answers to this. So you could check out the range operator. I believe range allows you to provide a step. Next week, when we're working with arrays, we'll see a very easy way of doing exactly what you just said when we have an array, because we can also provide a step on that one as well. I seem to recall range has that built in. Let's take a quick look and see if we can find it.
There's a joke answer, and you can just do an if statement for every single number until infinity. If what if one is
I can imagine. Is range part of? Yes. So range provides a step. So you have a start stop on the range function, but you can also provide a step. So if we go from 0 to 10 like that, how about commas? Like so. Why am I not getting my output back here? I will, the range operator returns an iterable is what it's doing. The range operator does not return a list. So if I put it into my for loop directly, for item in range 0 to 10.
It will work, I think.
Yeah, the range function does not return a list. It returns an object called an iterable. So the iterable goes perfectly in here. So it works when I bury it inside a for loop. So the for item in range, we can go 0, 10, 2, and then we can print item, and it's giving it a step. So the step parameter allows you to skip over. This stuff can be stored in a list. So this is all kind of next week's sort of topic. But yeah, I'm guessing there's probably several other answers to that as well. Okay, I got another one here for you. So let's try that, and we'll see if we can. These are good questions, though. This is where you kind of learn things. It's just asking lots of questions. So notice that I have done mean and cruel things and making variables hard to read. So part of the message here is don't do this. Make your variables very descriptive. So I just generated an example of the for loop there with the range function. So this is 0 to 5. Notice when I did this range, I did not get a 10. Notice that it stops at 9. But the 0 is inclusive. So the range function is inclusive on the left side and exclusive on the right side. Crazy. So this should go 0 to 5. All right, I'll warn you about that one because most people are going to get that wrong when you're guessing at range. Follow it through. I won't say any more. Where are we here? 1127. Give it a good 10 minutes. Have a go at it and see if we can produce what will it print.
Sir,
Yes.
for line 12, like the range 0 to 6, will it be like from 1 to? I'm confused, like with this exclusive and inclusive thing. Like,
That's why I wrote it here at line 11. This will go 0 to 5.
oh, okay.
Okay. So it would be written this way if we were going to, yeah, you could use a square bracket or in math, that is not Python, that is math notation. Okay, yeah. Yeah. So the math notation is square brackets are inclusive and the round bracket is exclusive. But what you need to know is that what I called UFA is going to go 0 to 5.
Sir? So on the line 21, the print statement. So the 3 before, like 2 column 3D. So the 3 represents the width of the answer, real, right?
Correct.
Okay, but here don't we have like 4 items that we will have in the print statement?
We do. They are numbered 0, 0, 1,
1,
2,
2,
3.
3.
We start counting at 0.
Yeah, I know, but like we only have like 3, like 3D, so it's okay to have like
No,
the width.
3D is just spacing.
Okay.
Yeah, so if I wanted to run this program again and I change this to a 22D, we can do that. So you got 22.
Okay, yeah. No, I understand. Thank you.
Yeah, but that's not necessary, but that's okay. Looks kind of cool. So this 3 is just width. All right. How'd we do? Harder? Easier? So that's what I get when I run the program. Let's take a quick look at what's going on here. And I'll put these programs up on Canvas for you later so you have a copy. Nobody asked me what this is, ABS. Anybody know what it is?
Absolute value. Kind of just absolute.
And what does absolute value mean?
Basically, if it's a negative number, it's going to turn it into a positive integer.
If this expression resolves to a negative number, it will make it positive. If this expression is a positive number, it does nothing. It just leaves it alone. So you're guaranteed that the result of calling this will always be positive. In this operator we've seen before, that is exponentiation. That is a number, which is the base, UPA, raised to the power 2. So we call that square. So that's this variable squared. What else have we got in here? That's about it. The thing to watch out for is the order that they're presented in, because that is 0, 1, 2, and 3. And you just got to get those twos matched up correctly to see what order your columns are going in. So if your columns look all screwy, that's the way it is. You got to be careful. So there's a nested for loop. So for every value in this range, for every value of UFA in here, we're going to burn through this loop however many times is needed. While UPA is greater than 10, it's going to go down. So those types of structures, nested iterative structures, they can be quite slow. These things can end up running for long periods of times because you have loop inside a loop. So this line of code can end up executing many, many times. I won't go through every line of it, but is that okay? Are people totally lost, or are we making progress today?
Yeah, I got it.
Yeah.
Can you please explain a bit?
So something like UMA, which is 33, that becomes a 26 when we subtract 7 from it. Now I'm going to add UFA, and the first time through it's a 0. So I know that UBA is now 26 because we subtracted
So
33.
I'm sorry to interfere. Like, how does UFA become like 0? Like, really become 5?
No,
Value?
no, the for loop is a loop. So the values for it's gonna run completely with the value of 0. So we're going through this code with UFA 0. And then on the next iteration, we go through the code with UFA value 1.
Oh,
So the for loop is a loop. It is a repetitive structure. Much like a while loop, we just code it differently. We keep track of those variables, add 2, and then obviously if we're in here, this is another loop. So this could go down quite a bit, but while we're greater than 10, we're going to stay in this loop. Then we square it. So the very first thing we do is square this thing to whatever that is, 11 or something, whatever that value is. And then this is the 9 squared, and we just kind of get stuck there. So that one doesn't change because we don't hit it again. Once UPA gets down to 9, it stays there, it just stays 9 squared. So these guys up here change. UFA, UBA, and UMA. So you would never write a program with variable names like that. If you handed that in, like, you would lose marks. Okay, so I'm allowed to do that for an exercise, but you can't do that when you're handing in an assignment or something. You have to use variable names that are descriptive. It's much more likely for you to make a mistake if your variable names all kind of look the same. That becomes very hard code to read. Any other questions about that one right now?
I have one question.
Sure.
So like in line 20, you wrote like, wait, I can show you only if, like, you know, if you go back to like explain it well. So like in line 20, you wrote like print and then, you know, 2:3D and then, you know, and so on. So why couldn't we like write it like, you know, in exact order, like starting from 0, 1, 2, and then 3, you know?
I mean, can you change these?
Like I meant, for example, like you started over here like 2:3D, and over there after dot format is like 0. So why couldn't we start with 0:3D, you know, 1, like in exact order, like?
Because I wanted to trick you. I wanted you to stumble on that. I wanted you to get messed up. Like yes, I could have put a 0 there, and that would have matched up. So that one would have been a 1, and then this one would have been a 2, and this one would be a 3, and everything would go in order. And that would have been easier. But I didn't want to make it easy. I wanted to make it nasty. I wanted to be mean. So I wanted to see if you were reading it and paying attention and just being careful. So yeah, it's purposely done silly. The other version of this, of course, I could just rearrange this side too, if you wanted to. I mean, anyway, you got to get comfortable reading these things. And so, yeah, I just wanted to make it, funny looking. Okay.
Yes, sir.
Okay. That's right. We're getting there. So I was going to do one more example today. I'm going to type this in for a couple of reasons. I want to go slow. And how would I say this? I want you to see the order that I work. I want you to see the sequence. If I put an example up on Canvas, all you see is the end result. And the end result is not how we work as programmers. We don't work that way. This is much more like the way that we work. We work from the inside out. We start doing things, and then we slowly start adding stuff to it to flesh out a solution. So I'm going to print out a menu, and this will be like a classic kind of a menu-driven application. And you can use this when we're done as a nice little template for any kind of menu-driven application. We're not going to build the entire ATM here. We're just going to build a little menu.
Can you please help me recall, like, what's the difference between like /t and /n? Like,
Good question. Let's see what else have I got here. I got one more here. I got to do a So /t is your tab character, and /n is the new line character. So I can force new lines and tabs directly into my prints, and just helps with a little bit of silly formatting. So I haven't done much. I've written a bunch of print statements, but you know what? Seriously, if I was working, I would go here and give it a try. Make sure it looks the way I think I want it to look. And it's laid out okay, and I like it. So I've done like 5 lines of typing, and I'm testing. Get the point? I'm testing right away. I want to make sure I don't have any bugs. And all I did was a bunch of prints. And I want to make sure that it's clean and it looks right. And then I feel comfortable adding things. So maybe I don't like that double new line character. Maybe I want to change it. So you fiddle with it a bit, but you're happy, and you start, you know, working with it. So we're going to get a so let's keep our tab going, otherwise that'll look funny. Like so. So we get a value from the user. The user has to put in A, B, or C. So we're going to have a menu-driven program here. So now we would have choice is, if choice is equal to something like so. So really, we would have a function call of some kind, and we would go do some work, but we're not going to write all of that code right now. We're just going to have a little print statement to see if we have our logic correct. What else do we want to do here? That's good enough. And now I've done a lot of work there. So like that's like a lot of typing. So you want to make sure it's okay. You're not missing any brackets. You're not missing a quotation mark. You haven't forgotten a colon anywhere. You don't want syntax errors. So you test frequently. You type for a few minutes and then test her out. So there's my menu. I hit A, and it says withdrawing money. So if I really wanted to be careful here, I could test all 3 of them and make sure that we're getting the kind of output that we expect: view balance, deposit money, withdraw money, et cetera, et cetera. So I'm feeling pretty good. Things are working all right. This is looking okay so far.
Sir, so like the slash tab, like, does it mean like it gives space?
It gives horizontal space. So this is your tab character right here. That's it.
Oh, okay.
Tab. It just moves over horizontally.
And slash, like slash n, you kept it in like in each because so it separates, right? Or if you wouldn't put it like be on the same line, right?
Yeah, so I given myself a little bit of white space just to make it look nice. The print will automatically give you a new line character at the end of the print. So you don't have to include it with every print. Print will automatically do it. If you want an extra space, just type her in. So if I wanted to call this from all over the place, we should write a function. So we should take this and put it into a function so that I can call it from all over the place. So I'm going to define a function at the top of my program. In other editors, this is really fast, but in Notepad, it's kind of like awkward. Tab everything over. Give yourself some documentation and notation so you very clearly indicate where you are beginning from. I'm going to get rid of that variable choice because I'm scoped now within my function. I'd like to use a different variable name. So I'm going to call it letter. And we are going to return letter. So now, with that one simple change, I've got much more sophisticated structure to my program, even though I didn't really manipulate any of the Python code. I just sort of rearranged it and put it into a menu. But line 14 can now be repeated from anywhere else in my program. So if I think this is a block of code that I'm going to use a lot, this is really, really smart to put it into a function and you can call it from anywhere. So let's run that because we want to make sure that we haven't ruined the thing. So once again, we can plow through it and put in all the different variables if we want and whatever, it's working. So I'm feeling pretty good now. I've got my function written and I've got a little bit of structure to my program. I'm going to have to run this program every time I want to do something. So that kind of is yucky. Like every time I want to do another, I should come back to the menu. I should be in a loop. I want to stay in this loop while choice. We can do all kinds of things here. Like so. Once again, I'm going to go tab everything in the hard way here. There's more than one correct format to this, but this is one format. This works. There's nothing wrong with this. I can initialize my variable to be something silly if I want to, just to get into a true block here and start running. Look what I got going for me now here. I got this loop is going to go forever until we hit a D. So while choice not D, we're going to do something. Well, choice is not equal to D. Yeah, we could do that. I think let's try that. Let's see what happens. There's different ways to write this, but that gives me a completely different flow now. So when I run my program, let's see what happens here. So if I give it an A, I withdraw the money, but look what happens to my program. I stay in the loop. I come back to presenting the menu again, and now I can choose to get out. So it's feeling pretty good. It feels like this is probably working okay. So you can test this a lot. You can test it with C and D and whatnot. But the point is that I can do a C to view my balance, and then I can do an A to withdraw money, and then I can say I'm done. So you get the option of entering again and again and again. I just add
So
while loop.
like from A to C, like it repeated. Like when you press D, we moved, like it exited, like, right?
Correct. While choice is not D, stay in the loop. And the menu call is in the loop. So we're going to call the menu again and again. When the choice is equal to D, all of the ifs will fail to evaluate because it's not A, B, or C. We come back to line 15 and the program ends. Program's done. So this is better, but notice the order that I'm writing all this stuff in. I started with some prints. I added some ifs. Then I decided, you know what? This would go much better in a function. And then I decided, you know what? This isn't really very good. I need to add a while loop. This is how programmers think. We do not write this stuff top to bottom. It's all over the place. We're up, we're down, we're here, we're there. And this still isn't done yet. I'm still not happy. Like this, what happens if I type banana or apple or grape or something? Like, we haven't done any data validation at all yet. So that makes me nervous. So our program could be improved here. So how about we go if letter, there aren't very many things that are valid. So I'll test for validity. I realize we haven't taken care of lowercase. It would have been kind of nice if we had both upper and lowercase, but we're not going to do that right now. I'm going to test for validity. And when I know that I've got a good letter, I want to get out of a loop. So I'm literally going to create a loop in my menu that constantly asks for another choice, another letter, if it's not one of those. So if I put in E, F, G, H, I, J, K, L, this if statement is not going to execute successfully with a true. We'll never do this. So if I get a good piece of data, my Boolean flag stay becomes false, and we break out of the while loop. While true, stay in the loop. So I'm going to stay in this loop as long as you enter bad data. So that's a significant change to my program. Let's see if we can run that one and get something to crash for us here. I haven't had any errors here today. I'm doing pretty good. So if I put in apple, nothing happens. We just stay in the menu. You put in rubbish, nothing happens. Put in the letter E, nothing happens. Put in an A, and we withdraw money. So we've got our software is now a little tougher. It's a little bit more rugged. We can put in some garbage and we're not desperately relying on the user to actually enter a correct value. So this is feeling a little bit better. I'm still not happy. I want to add more to this. I'm not really happy with this yet, but we're doing pretty good. This menu is grotesque on the screen because it's scrolling horizontally. I don't really like that. That's not really cool. So let's see if we can improve on that one a little bit. When I'm working at the operating system level, when I'm at the command line and I type things like this, CLS, it clears your screen. Well, that's a really nice feature, and I can use that directly inside Python. So a couple of different places I can put it. Where should I put it here? I should put this in my while loop every time I want to print the menu. I can go like so and clear the screen. So the CLS, which is the clear the screen command, I can pass that out to essentially DOS or the Windows command line environment and have them execute a command. So that's much better. So now my menu is going to stay in one spot. It's going to look a lot more appealing. So now I cleared the screen. Now watch what happens when I do this. So I'm going to put in an A, and I should work, but what's going to happen? You see it flash? I put in the A and it flickers. It's like it did the withdraw money. It's doing the code correctly, but it's just gone. It's just flashing right by, and there's nothing to stop the program here. There's no stop. So we do the withdraw money, but we immediately call menu, which clears the screen. So that's not very good. I mean, it's the right idea, but it's not very good. So there's a few ways that we can fix that. One way is to do a pause. So after I finish a print, throw in a system pause, and that will halt my, now I've just edited a file which is live running. So that's always a bad thing to do. Don't edit programs that are running. That would be a mistake. Python menu example. Now when I do the A, I get the screen freezes. This is my pause. So it comes out coded just like that. Press any key to continue, which is cool because that's exactly what I wanted to happen. So that's the line 29 system pause. Now I've got to hit any key to continue, and the thing runs. So it's kind of nice. And we've got a lot going on there for us. Like we packed quite a bit of this semester is packed into that one example. We've got if statements, we're validating data, we've written a function, we've got while loops going on forever until we choose to exit. That's a template. Take this program, I'll put it up on Canvas, and like literally like memorize it. Like, I mean, just write it out. You should be able to write this kind of stuff. A loop, an if, and a function. Like you should be able to do that. Okay, the system calls, that's just sugar. You know, that's just candy stuff. That's not the point of the course. Like system clear the screen. That's just fun stuff to clean up our display. A loop, an if, and a function. That's like your next test. There you go. One program. A loop, an if, and a function. So I'll put this up there, and you got to be able to do this. You got to be able to write these. So just try it. Just try writing stuff like this. And then you can peek at the answer when you get stuck. And you can just look at my program but that's the kind of level we're shooting for in the next few weeks, is to get you to this kind of level. Loops and ifs and functions. That's pretty big. That's quite a bit of work considering where we've been all semester. Anyway, questions? I'm going to stop there today. That's all. I'm done talking.
Sir?
Yeah.
So when we use here like stay equal true and at the end stay equal false, so it's similar to when we use the flag, the same thing, just different name?
Yes, exactly same thing. So you can call it a flag, make up any variable name you want, semaphore. I like using I'm done, so or not done. So while not done, like whatever you want to, whatever.
Okay. Yeah. Thank you.
You're welcome. How we doing, people? Any other questions about this little one? I'm going to stop the recording there.